Hi, welcome back. In this video we're going to look at higher degree polynomial equations, and particularly those that can be put in a special form. We'll talk about that here in a second. Okay, first off, what is a polynomial equation, in this case of degree n? Well, it's an equation of this form, so it's a sub n x to the n plus a sub n minus 1 x to the n minus 1, plus we continue decreasing the index here, and then decreasing the power on x till we get to a1x plus a naught equal to 0. We're talking about an equation, so we've got to have an equal sign, it has to be equal to something, it has to be equal to 0. All right. These a sub n's, so a sub n minus 1, and we have an a sub n minus 2, and so on, down to a1, and then a naught, a sub 0. These are the coefficients of the polynomial. Now, you're familiar already with polynomial equations of degree 1. Those were linear equations, in which case we had an mx plus a b. So the m would be the a1 and the b would be the a naught. We also have looked at quadratic equations. These are second degree polynomials. Those would be a 2x squared plus a1x plus a naught, although we usually used a, b, and c, especially with the quadratic formula. This is just a general polynomial, so higher order degree, higher degreed polynomial, and there's really no limit to this, right? We could have a 20th degree polynomial. All right, now we're typically interested in, since we have an equation, finding values of x that solve the equation, right? And for higher degreed polynomial equations, we have to work a little bit harder to find the solutions. And eventually you're going to pick up an entire suite of tools that will help you find those. But in this particular video, we're going to look at some special cases. All right. The first case we're going to look at is when this fits what's called a quadratic form. And these are not second degree polynomials necessarily, but they can be made to look like a quadratic. So let's look at this. So we're interested in quadratic form, and that's something that looks like this. So it's something we can write as a squared plus a, so say, write this, say a2, a1, and then a naught. So quadratic form of this type, so we have just some coefficient times a squared, and a is some algebraic expression. So a to x a squared plus a1 times a plus a naught equals 0. This can then be solved like a quadratic. So we could use the quadratic formula, we could factor, whatever. And then once we have capital A equal to some number, right, we can then solve for the variable. Right? So we want to solve this and then make our replacement for A. Right? Let me illustrate that with an example. So here we're asked to solve the equations. And this first equation, z to the fourth plus 27z squared minus 324 equals 0. All right. First thing to notice is that this is a fourth degree polynomial equation. And so using the quadratic formula or factoring won't work directly with this. But it does fit this quadratic form. We can see that this first term is something squared. This is that thing that is squared, right? And then we have the constant over here. The thing that's squared is z squared, right? Z to the fourth is z squared squared. So I could write this z squared squared plus 27 times z squared minus 324 equals 0. This z squared is our a. So you can see we could take z squared out and put in a, and this would fit this form exactly. All right, so we want to solve this, and we could factor or use the quadratic formula. And this does indeed factor. We need factors of negative 324 that add up to positive 27. Right? That happens to be 9 and 36 with the negative on the 9. Right? So we'll have this z squared minus 9 z squared plus 36. All right. Now to get this 9 and 36, what we need to do is to take this negative 324 and factor it into two factors that add up to 27. Okay. Now once we're here, so we've now factored this. Now we can solve each of these. So we have z squared minus 9 equals 0, and or z squared plus 36 equals 0. And that means z squared equals 9, or z squared equals negative 36. And now we can solve for z. So z squared equals 9. We know that z is either plus 3 or minus 3. Take the square root here, and we get plus or minus the square root of negative 36, and that's 6i or negative 6i. Right. And so the solutions, right here, we have 4 of them: 3, negative 3, 6i, and negative 6i. All right. Let's look at another quadratic form: 2x to the 2/3 minus x to the 1/3 plus 3 equals 0. Now don't let the fractions in the exponent scare you. The denominator here represents a root, so that's x to the 1/3. That's actually the cube root of x. This 2 here acts like a square, so this would be the cube root of x squared. All right. This is in the quadratic form, and we can treat the a as this cube root of x. So let me rewrite it in that form. So we'll have 2 times x to the 1/3 raised to the second power minus 7 times x to the 1/3 plus 3 equals 0. All right. Now you should be able to see, so 2x to the 1/3 squared, the a, so this is x to the 1/3, and then the a here. Right, now it fits that quadratic form. 2 something squared minus 7 times something plus 3 equals 0. All right, this also factors. So we can see that the middle term is negative, and so we know both of these are going to have to be minus. Middle term's negative, and this is a plus. So the last two terms multiplied together has to be plus, and they need to add together to be negative 7. Don't have much choice here for the first one. We're going to have 2x to the 1/3. And then over here, we have x to the 1/3. And now we need to put the 3 in the right spot. So we'll put it here, and I think that will work because we've got 2 times negative 3, which is negative 6, and then negative 1 times x to the 1/3 gives us negative 1, so that's a total of negative 7. Negative 1 times negative 3 is positive 3. 2 times 1 is 2. All right, good. Okay, so we have 2x to the 1/3 minus 1 equals 0, or x to the 1/3 minus 3 equals 0. And now we solve both of these equations for x. So we'll add the 1. 2x to the 1/3 equals 1. Divide by 2. X to the 1/3 equals 1/2. And then to undo the 1/3 power, we will take the cube of both sides. So that means x is 1/8. 1/2 times 1/2 times 1/2. Okay, the other one here, we've got x to the 1/3 equals 3. Again, we need to cube it, so we need to take 3 times itself 3 times. So 3 times 3 is 9, times 3 is 27. So x equals 27. All right, so these are higher ordered or higher degree polynomial equations that fit this quadratic form. In the next video, we'll look at what to do if you don't have this quadratic form.